Hello everyone, today we'll be solving a problem. It's called maze solving problem. So we are given a problem. For example, we are given a matrix. So let's assume we are given a matrix of 3 by 3. So which will look something like this. So in this, I'll expand it. So this is the matrix of 3 by 3. So 3 by 3 matrix, that means is 3 by 3 is, for example, n cross m, where n represents the number of rows and m represents the number of columns. Okay, so we have 3 columns and 3 rows for in this case. And in our programming case, I mean, if we look through the coding perspective, we'll be naming them as 0, 0. We call this one as 0, this one as 1, this one as 2. Similarly, the other side, this one is 0, 0, and this is 0, 1, 0, 2, and similarly, this is 1, 0, 2, 0, 2, 1, so 1, 1, and then we have 1, 2. This will be 2, 1, and this will be 2, 2. So, for example, we have this matrix. So, what the question has stated is we have to find the we have in this question we have to start. For example, we are standing over here in this question currently, and we have to reach this point, which is 2, 2. So, to reach this point, you have to calculate the maximum number of ways to reach this point from our initial point to our final point. You have to calculate the maximum number of ways. That is our problem. And there are two conditions which we are given. First condition is you can only move in the right direction. Wherever you are, you can only move in the right direction. You can move in the right direction, or you can move in the down direction. There is no diagonally moving allowed. So you have to either move in the right direction or you have to move in the down direction. These two are the only things move that is allowed in this problem. So we'll start the problem. So we look at the code that is for this problem. So first of all, we'll be asked to define a function for this code for the problem. So first, we'll keep a function name as the total path. So for example, we are so in Java syntax, we'll be writing it as public static. I don't think this color is visible. I'll take a black color. It is a public static, and we won't be keeping our function as void because we'll have to return the number of ways it is calculating at the end. So we'll be keeping it as int, the return value, the return type, public static int, and then our name of the function, we are keeping it as count path. We'll keep count paths, and then we'll be passing 4 parameters in this function. First will be the initialization index, for example, where we are standing currently, from where we have to start moving. So we'll be passing that. So for example, will be int I, and then int I is the row, and then for the columns address, we'll be passing int j, and then we have to pass the whether which and then n cross m. So we have to pass the value of the matrix. So what's the size of the matrix that we'll be passing in our next 2 parameters? Will be int n and int m. Okay. Now we'll start writing our function. So now what we do is we'll declare some base case. As we know, every recursion function, whenever we are solving a problem using recursion, we have some base case. So we'll be leaving some space for the base case to be written over here. And after that, we'll be writing the main codes in our function. So the first code that we are going to write is first wherever we are, we'll be asked to move down first. So we'll be moving down. So for that, and also there it is the function. It is storing some value. It is storing some value. The function is storing some value. So that will be stored in that has to be stored in a variable. So we'll be using int down path is equal to, we'll be writing a function name since it is a recursion function, paths, and then here wherever, so for example, if you're moving down, so I has to be increased where the j will be remain as it is. So if you're moving towards down, the row number is increased whereas the column number remains as it is. So we'll be writing I plus 1, j will be as it is, and n or m will be as it is. Again, now we have written the statement for moving down. Similarly, we have to write the statement for moving towards the right. So we'll be writing that int right paths. So it will again return the number of paths. So we'll have to store in this variables. So for right path, we'll be storing in this count paths. Again, we'll be calling the same function. And this time, I will be leaving I as it is. In this case, we'll be increasing j, the column number. So for example, if it was over here, they should increase by 1 in the next box. So we'll be writing j plus 1, and n and m will be as it is. Okay. Now what we have to do is we have to return something, right? So we'll be returning. Okay. We'll be returning the summation of these two, and then it will be going to the next recursive step. So we'll be returning down paths plus the right paths, and then it will be given, and then it will be repeating as per the requirement. So now we didn't mention any base case, so we'll be mentioning the base case now. Here we'll be writing the base case. So what will the base case? Our base case is that the moment we reach over here in the corners, it should not be allowed to go. If it is moving towards down and it has reached the corner cell, it should not be allowed to go any further from here. And also, if we are reached to the final destination, we should not be allowed to move any. We should return 1 at that time. Okay. So we should not be allowed to move further after reaching corner point. And in this special case, we should be terminating our recursive step and then terminating the layer, and we should go to the previous layer, and we should start again, because when we have already reached here, so we have to go back and then we have to start a recursive step again, so that we can reach our destination once again. So using that backtracking concept, we'll be doing it. So first, the base case will be declared. So in case, we'll be writing two conditions in this. If I is equal to n minus 1 and j is equal to m minus 1. In this case, what we have to do is we have to return 1. Okay, in this case we'll be returning 1, and the second base case will be if I is equal to n or j is equal to m. In this case, we have to return. In this case, we'll be returning 0, because this has reached the corner point, which is not the final point, it's just the corner point. In this case, we'll be returning 0, and in this case, we'll be returning 1 when it has reached the final point. So 1 indicates that it has reached the final point. Now we should go back to the previous recursive step and then continue from there, because 1 we have already calculated. So now this is the actual code, and now we're going to write. Now we're going to understand this code actually. So when we run it, what is the output that should be expected? And again, the other thing that we'll be doing is forming the layer, because as you know, in recursion, in recursion function, what happens is that there's a formation of layers. So once we start a recursion, so we have some layer, but some layer is formed, and then if we move to the next recursion step, again the function is called. There's formation of another recursion, another layer. It goes in the form of a stack, and then we have to keep tracking the stack as it returns the value of 2, strike off the stack layer, and then we have to go in that way. So we'll be seeing how that works. So this is the actual code, and at the end we'll be calling our main function. So the public static void main, we can write that. So I'll just in short, I'll write the main function. It has the string and like args. So in this we'll be calling our the function that we made, which was count path. So we'll be mentioning count path, and also we have to print it. So we'll be directly printing it. So that will be system.out.print. We'll be printing a count path. This is the main function we called count paths. In this count path we have to pass. We have to pass the value. So initially we are standing at 0, 0, and then the n cross m, the size of the matrix we will pass. So for example, we'll be passing the matrix 2, 2, 2. So this is the matrix that we'll be passing now, and then we'll be closing this, and then we'll run this program. So in this case, this is the 3 by 3 matrix. So we have used 2 by 2 over here for the ease of understanding. So if you understand 2 by 2 matrix, it'll be easy for you to understand the it is the basic of the matrix problem that we're solving. So that way you can solve all the problems if you understand 2 by 2 matrix or 3 by 3. So we'll be going with the simpler one. It's not a simpler, but just a little lesser step than the 3 by 3 matrix, because 3 by 3 will cross the it will take so much space and it will consume so much time. So when we're solving a 2 by 2 matrix, it's all the same, just a little lesser steps. So we'll be doing that. So now I would erase this one and I'll convert it to 2 by 2 matrix. Okay, this column this row is gone. So now it is a 2 by 2 matrix. So again I'll erase from here. Now it has become our 2 by 2 matrix, where our initial point is this, our final point is this. So to reach over here, so how many ways we can do that? So we can either go from here and here, we have reached, and also we can go from here and here, we have reached. So there are a total of 2 ways we can do this. We can solve this problem. So now we'll be understanding how do we do that. Okay, now let's do it. Okay, so it's solved in this case. Okay, so now as we call, we'll start from here from the main function. So as we call the first layer, for example, will be our main layer. So that passes the index 0, 0. Okay, this is the index that has been passed. Okay, next we will name the layer as 1. Okay, next we go. As soon as the function is called, our control will be shifted inside the function that we made, and then if conditions will not be, it will be checked, because but it won't be true. So we'll be immediately moving towards these 2 steps. So first step says down path. So in this again the function is called as a recursion. So in this the row is increased by 1. So next our the function is called, so we're making up the second layer of the recursion stack. This is a stack. So for understanding, we are making this. This is a stack of the recursion, where we'll get to know all get to know about the functioning, how it is happening in the background, how the answer is coming. So that will be getting through the stack formation. How if we form the stack, we'll be able to track the function that is happening. So this is main. So our so next this line will be executed. Okay, because the base case are not coming through, so we'll be coming over here down paths. So now this again the function is called, and it is called increasing the row value. So now down. For example, we'll be calling this line as down path. So sorry, we'll call it as down for short. Okay, down. And now the index value is 0 plus 1, and in, the column value is 0 as it is. Okay, down is called. So now again down is called. So again we'll start the function. Okay, now our if you have to track, I'll make one more matrix over here. It'll be easy to understand. Okay. This was our matrix. This is the 2 by 2 matrix. 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now in the main function it was here, but after once this function was called, our the pointer came over here, 1 comma 0. Okay, again, if we once this one was called, again it will go inside this, but now the index value, the row value will be 1. So now if this one is again called, so now again third step would be to call down. Okay, now it was 1, so now it has increased one more time, so it will be 1 plus 1 has to be 0. So now our n value, as you know, it was 2, n value was 2. So you have to keep these things in mind. In this case, our n value is 2, n value is 2, both n and n is 2. So now in this case, when this function is again called with 2, so if you look in the base case, so if I is equal to n, so in this case I is equal to 2, so in this it will return 0. So one of our base condition has reached because this corner value has it has come to the corner value, so it cannot further go down. So that is why 0 is will return over here. So this will return 0. So as soon as it returns, it is strike off, and this one is return 0, and then it will, the control will, it has returned 0, and then what happens is we'll again skip this. Now it has returned 0, so this will go off, and then again after this we'll be going to this. So in the previous case the index value was 1, so we'll continuing with 1 and 0. So now right path will be called, so we'll be writing 4 over here, we'll be having right. In this case 1 was here. Okay, we don't have to consider this, we have to consider this value 1, and then it was 0 initially and it will increase by 1. So now it has reached over here. Okay, 1 comma 1, that means it has reached over here. And if we look 1 comma 1, so if we look in the base case condition, it will again call this with increase by, we have increased the column value by 1, and it will go back to the function. We'll restart the function, and once it restarts, we can see that we have already reached one more base condition over, which is I is equal to n minus 1, j is equal to n minus 1, which is I is equal to 1, j is equal to 1. We have reached that condition. That means we are in the corner. We are at the destination. This statement means we are at the destination. So it should be closed. Okay, this means if we have reached the destination, this will give 1. Okay, as soon as it gives 1, we'll go. Now this one is given 1, and then we'll go to the return statement, which is down path plus right path. So down right path was 1, down path was 0. 1 plus 0. So now it has returned. So we'll strike this. So down path is 0 and right path was 1. So it will return this value. So 1 plus 0 is 1. Where this value will be returned? That's the question. It will be returned to the last statement, last unstriked statement. This is the statement of unstriked. So we'll be returning to this. 1 plus 0 is 1, so 1 will be returned to this. Now we'll be starting again from this. Okay, now these two values are strike, stroke, whatever. So now it's starting from down. So down we'll be starting with 0, 0. Okay, this previous value will be starting, not the added one, the previous one. Not the added one, the previous one, 0. So we'll be starting from 0. So 0, 0. So that means again we have come to the initial position. Okay, now but we'll be starting from here after down. So this we will be down. We'll be starting below this. So this goes away. So we'll be going for right. Okay, so this will be the call for the right path. Okay. In this case, the 0 was initially, and even the column was 0 initially, but then we'll be increasing by 1 because the condition is increasing by 1. So in this case, it has reached over here. Okay, 0, 1. Again, if it will, now it is called the same. It is called the function. So again, we'll have to start the problem, and does not reach any base case. So we'll be going to the next statement, which is down path. So we'll be writing down path, and this down the row will increase by 1, and column is as it is 1. So now if you see, it has reached the base case. If 1, 1, it will come down, and it has reached destination. So it has reached the base case, which is 1, 1. So this will be true, and then 1 will be returned. This will return 1. Okay, and this will be returned 1. Okay, as soon as this one returns, you can strike off this, and then we continue from here because it has returned 1. 1 has been given to this variable, and then this will be called. So this 7th one will be having, which will be right path again. So the previous value was 0, and the previous value was 1. Okay, this value you have to consider. This one 0, this one is 1. 1 will be increased by 1 because that is what the condition is in our function we have mentioned. So it is 0, 2. So as soon as it is 2, again the base condition is being reached, which is we have crossed the bottom border. We cannot do that. So this will return 0. So it will return 0, and again we have to strike off this one. Now this statement is executed. Now we'll move to the last statement, which is return down path plus right path. So this was right path. This is down path. 0 plus 1 is 1, and where this 1 value will be going, this return, this will give the answer. This will give the answer of 1, and this 1 value will be given to this variable right over here. Okay, this will be given because this has not been assigned any value, so we'll be giving this because this is the this was the last statement that was executed. So whatever values coming from the upper statement will be given back to the lower statement, since we are backtracking. Okay, as we are coming back from the recursive statements. So this 1 will be given, and then now as we backtrack, we have to start from here. Okay, this is the statement which has not been this is the statement where we paused last time. So we'll have to start from here, right? 0, 0. Okay, so we have to start from here, right? Again, if we start from here, the next statement is ultimately the return statement, which is down path plus right path. So you have to add the right path, which is 1, and the down path, which is 1. So this is 1 and 1. We have to add this, which will give us 2. Okay, now it will give us 2. These two values. Okay, this is right off. These two values, which is 2, and where this 2 will be returning, this 2 will be returned to the last statement. Okay, this will be striked off. Okay, now that has been assigned the value, you can strike off these two statements, and then it will return the value 2 to the main statement. That is how the main statement will be given, and this statement will return the value 2, and 2 will be printed out in a system.out print. That is how we'll be solving our problem, which is the maze problem. Okay, so in this case we have got 2. Similarly, you can try with 3 cross 3 and 3 cross 2. Similarly, the same thing will happen. So that is it. I hope you liked it. We'll be making such more videos. Just help us and support us in our process. Thank you so much.